Dear friends, welcome to my YouTube channel. I am Dr. Musaddiq Gohir. I am here with series of lectures about the angular momentum in quantum mechanics. So let's start from the very basic of angular momentum in Cartesian coordinates. We are talking to the reference of quantum mechanics. So, by basic definition of angular momentum, we know that it is the cross product of position vector r and linear momentum. So, when we talk about quantum mechanics, then observables are always represented in terms of operators. So, the operator representation of angular momentum is given by P is equal to minus iota h cut del. Place this, then the angular momentum takes the form like that. R is the position vector which is equal to x I cap plus y j cap and z operator is given by partial x I cap plus by partial y j cap plus by partial z k cap. So we can replace these parameters and we know that the cross product of two operators can or two vectors can be written in terms of a determinant. We take common minus iota h cut and determinant can be written as for two vectors whose cross product we want to evaluate ijk, and below in the column of I cap we will place the coefficients of I cap. First r position vector coefficient, then x, and partial by partial. Like, this is a very basic technique. I hope so every student of quantum mechanics knows about that. Now we will expand this matrix a determinant by first row. So L is equal to Lx I cap plus Ly j cap and Lz k cap. Lx, Ly, Lz are components of total angular momentum L. So when we place the values of L instead of when we place the values of components instead of total angular momentum and expand the determinant by first row, then we will receive this kind of relation. So it is very basic technique, and every student must know how to solve determinants or expand determinants. Here we can see that on the left hand side we are dealing with the components of total angular momentum, and on the right hand side we are dealing with the uh, uh, expansion of determinant with respect to ij k. So from here we can compare the coefficients of I cap, j cap and k cap. When I want to compare I cap, then I will get Lx is equal to iota h cut into z partial by minus y partial by partial z. Now this is the value of Lx angular momentum in Cartesian coordinates. Okay. In the similar way, when I compare the unit vector j cap on the left and right hand side, then Ly will take that form, and in the same way I will get Lz by comparing the coefficients of k cap. So now the components of angular momentum are given here in the Cartesian coordinates. So this was our lecture about the angular momentum in Cartesian coordinates, and I hope so you find it useful, and it is very easy to calculate the components of angular momentum. I will be back with new video and with new series of angular momentum lectures. But this was the basic one. You have to watch this and remember these components to evaluate angular momentum in spherical coordinates in the upcoming lectures. Enough for today. I will be back with new video. Allah Hafiz.